Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel and click on the bell icon to receive the notification for the upcoming problem solution. Now I am going to solve this problem 4.5. In this problem we are given this loaded truss and we are asked to determine the force in each member of this loaded truss, right? So we have to find the forces in each member of this given truss. So first I will find the reactions at this point A and D. Since at this point A we have this roller supports, so there will be only one reaction. So let's say that this is the reaction, this is the vertical reaction, and let's say that this is our positive x and this is our positive y direction, right? So then we can say that this is a y reaction, and at this point D we will have two reactions as well. Since it's a pinch joint, so we will have one reaction in this direction. Let's say this is dy, and we will have one reaction, let's say, in this direction, so this will be dx. So now if we apply the summation of moment at point D equals to 0, right? So if I write that the summation of moment at point D equals to 0, so we will consider the whole truss while finding the reactions of this given truss, right? So we will say that we will find the summation of moment about this point D, and let's say that the counterclockwise moment is positive, right? Let's say. Now as we can see that this AY is producing clockwise moment about this point D, right? So we will write minus, and the perpendicular distance of this AY from this point D is this 3 plus 6 plus 3, right? So this as a whole become 12 meters, right? So I will write 12 AY, right? And as we can see that this 4 kilonewton force is producing the counterclockwise torque about this point D, right? So this will try to rotate the whole truss like this, that is the counterclockwise, right? So we will write that this is plus, and the perpendicular distance of this 4 kilonewton from this point D is this 6 plus 3, right? So we will write 9 into 4, and similarly in this 6 kilonewton force is also producing the counterclockwise moment, and the perpendicular distance is 3 meters, right? So I will write plus 3 into 6, and this will be equal to 0. So this will give us AY reaction. So AY comes out to be 4.5 kilonewton, right? So this is the reaction at this point A, so I can write that this is 4.5 kilonewton, right? So if we apply the summation of forces along x equals to 0, and if we consider this whole truss, so there is only this dx, this reaction in the x direction, so this means that dx is equal to 0, right? So this means that there is no reaction in the x direction, so we have to remove this, right? Now if we apply the summation of forces along y equals to 0, and as we can see that this AY is acting in the positive y direction, right? So we will write, and this dy is acting in the positive y direction, right? So I will write dy plus this 4.5 kilonewton, and this 4 kilonewton is acting in the negative direction, and this 6 kilonewton is acting in the negative direction, so I will write minus 4 and minus 6, so this will be equal to 0. So when we solve this equation, so dy comes out to be 5.5 kilonewton. So now we know this reaction as well, so this is 5.5 kilonewton. Now to apply the method of joints, we have to select that particular joint where we have at least one known and two unknown forces, right? So now we can start from this point A and we can start from this point D, right? Since at this point A and D we have this one known reactions and two unknown forces. So let's say that I start from this joint A. So if I write that this is joint A, and since this whole truss is in equilibrium, so this joint A will also be in equilibrium, and this means that at this point A, the summation of these three forces by head to tail rule will be equal to 0, since the summation of forces in equilibrium is always equal to 0. So now as I have told you people that we have to select the direction of this AB force and this AF force in such a way that these three forces should make a closed triangle by head to tail rule, right? So now if I say that this is the direction of AF force, right? So if we say that this is the direction of AF, if I draw it like this, so this is AF, let's say, and this is the reaction force, let's say this is the reaction force AY. So in order to make a closed triangle, so then AB must have a direction like this, right? So the AB must be acting like this, right? So this is AF, this is AY, and this is AB, right? So this means that this is the actual direction of AB. This means that AB is the compressive force and AF is the tension force, right? Now we have to find this angle as well, right? So we are required to find this theta. So right, this is the angle between AF and AB, right? So this means that we need to find this angle, right? So this angle is theta. So now we know the dimension of this triangle, so we can find this theta by using the tan theta, right? So we can write that tan theta, this angle is theta, right? Remember, so the tan theta is equal to 4 divided by 3, and theta will be equal to tan inverse 4 divided by 3. So this will give us theta angle between this AB force and this AF force. So let me write that this is AB and this is AF. So this theta comes out to be 53.13 degrees, right? So now we know this theta. So now from this closed triangle, this means that the magnitude of this AF will be equal to the cos component of this AB, right? So this, if we resolve this AB into its components, right, so it will have one component in this direction and it will have one component in this direction, right? So this means that AF will be equal to the cos component, right, since we know this theta. So this is the cos component of AB and this is the sin component of AB, and this theta are equal, right? So now we can say that, and we know this AY magnitude, which is 4.5 kilonewton, right? So now first we can say that the sine component of AB is equal to AY, right? So we can say that AB sine of 53.13 equals to this AY, which is 4.5 kilonewton, right? And we can find this AB. So AB will be equal to 4.5 divided by sine of 53.13. So from this equation we get AB equals to 5.63 kilonewton, and this force is the compressive force since this is acting towards the joint, right? So this is the force acting on the joint. So as a reaction, the joint will apply the force on the AB member, which will be opposite to this direction, right? So that force will compress this AB member. So this means that this AB force is compressive and its magnitude is 5.63 kilonewton. Now as we can see that this AF is equal to the cos component of AB, so I can write that AF is equal to AB cos of 53.13, and now we know AB, so this will be 5.63 cos of 53.13. So this will give us the AF magnitude. So AF comes out to be 3.38 kilonewton, and since it's acting away from the joint, so this means that this is the tension force, right? So now we know these three forces, right? So now I will solve this joint D, since at this particular joint we again we have two unknown forces and one known force, right? So if I write that let's say that we apply the same method for joint D, right? So we will have to assume the direction of this DE and CD force in such a way so that they should make a closed triangle by head to tail rule, right? Since we have these three forces, right? Now if I draw this dy reaction force, so let me draw that dy reaction force. These three forces should make a closed triangle, remember, right? So if this is the dy force, so then if we want to make a closed triangle, right, so I have to first only draw these two forces, right? So one force is horizontal, right? So this is the horizontal force, right? And so then we need to have another force in this direction, right? Right, so this is dy. So in order to make a closed triangle by head to tail rule, so this DE force should be in this direction and this CD force should be in this direction, right? So they will make a closed triangle. So this is gy, which is 5.5 kilonewton. This is DE force, which is unknown, and this is CD force, which is unknown, right? So now we can specify the direction, right? So this is the direction of DE and this is the direction of CD, right? And this is CD and this is DE. So now again, as we can see that this triangle and this triangle both are same. So this means that this angle will remain the same. If this is 53.13, so then this angle is also 53.13. So this means that this CD force is making 53.13 angle here, right? So if this is 53.13, so then this is also that theta. So now again, as we can see that if we resolve this CD force into its components, right? So then this dy will be equal to the sine component of this CD. So we can write that CD sine of 53.13 if we consider this theta, right? So this CD sine of 53.13 will be equal to 5.5 kilonewton, right? Since this is acting opposite to the sine component of this CD, so both of these will be equal, right? So this means that CD will be equal to 5.5 divided by sine of 53.13. From this equation we get CD equals to 6.88 kilonewton, right? And since this CD is acting towards the joint, so this means that this is the compressive force, right? So I will write this is compressive. And now as we can see that the cos component of this CD will be equal to DE. So now we can write that DE is equal to CD, and we know the magnitude of CD, which is 6.88. So 6.88 cos of 53.13. From this equation, DE comes out to be 4.13 kilonewton, right? So this is 4.13 kilonewton, and since this DE is acting away from the joint, so this means that this is the tension force, right? So we will write tension T with it. So now we know this CD and this DE force, right? So now at this we can solve this joint C as well, right? Since here we have three forces and one of the force is known and two are unknown. So let's say that if this is CD force, so then it will be acting in the opposite direction at this point, right? So now we know this CD. So again we have these three forces, so we have to specify the direction of these two in such a way that by head to tail rule they should make a closed triangle, and by head to tail rule the resultant of these three forces should be equal to 0. So now if I draw this force, let's say if this is my CE force, let's say if this is our CE force, if I write that this is CE, and if this is my BC force line, let's say we do not know the direction, right? So I have to place this without an arrowhead, right? And then this is our CD direction, which is known, right? So this is our CD direction. So this is our CD direction. So in order to make a closed triangle, CE must have the direction like this, and BC force must act like this, right? So in order to make a closed triangle, right? So this means that this is that BC, this is CD, which is known, which is 6.88 kilonewton. This is CE, which is unknown, right? And this BC, this is also unknown, right? And as we know that this CD is again making that angle 53.13 with the horizontal, right? So we know this angle as well. So this is 53.13 degrees. So now again we can say that BC is the BC magnitude will be equal to the cos component of this CD, and the sine component of this CD magnitude will be equal to CE. So now if I write that this is joint C, so now we can write that this BC will be equal to, we can write that BC is equal to 6.88 cos of 53.13, right? And we can say that CE is equal to 6.88 sine of 53.13. Now when we solve these two equations, so we get BC equals to 4.13 kilonewton and CE equals to 5.0 kilonewton. So as we know that BC is acting towards the joint, right, from this triangle, right, and CE is acting away from the joint, right? So this means that CE force is tension force and BC force is compressive force, right? So now we know this BC and this CE force. Now we can solve this joint B, we can solve this joint F as well, and we can solve this joint E as well, right? So first, now I will solve joint F. So since we have more than 3 forces, so now we can not apply this triangular method, right? So this triangle method. So now we will simply apply the summation of forces along X and the summation of forces along Y. So now if this is the direction of a F force, so then it will be acting in the opposite direction at this point, at this joint F, right? So now we know the direction of this 4 kilonewton and we know the direction of this AF force, right? So we have to assume the direction of both of these. So let's say that this BF force is acting in this direction, let's say, and this EF force is acting in this direction, let's say. So let's say this is EF force and let's say this is BF force. So now if we apply the summation of forces along X equals to 0 at this particular point, so now as we can see that this EF is acting in the positive X direction, so I will write EF minus and this AF force, right? So EF minus AF equals to 0, or we can say that EF is equal to AF, and we know that AF force is 3.38 kilonewtons, right? So we will write that this is 3.38 kilonewton, and since EF force is acting away from the joint, so this means that this is the tension force. So now we know EF force, and now if I apply the summation of forces along Y equals to 0, so as we can see that this BF force is acting in the positive Y direction, so I will write BF minus this 4 kilonewton, so I will write minus 4, and this will be equal to 0. So this means that BF is equal to 4 kilonewton, and since it is acting away from the joint, so this means that this is the tension force. Now we know this AB force as well, right? So AB force is known at this joint B. This BC force is known, it will be acting in the opposite direction. This BF force is known, right? So at this particular joint we only do not know the magnitude of this BE member force, right? And at this particular point, again, this is the direction of EF force, this is the direction of DE force, so again only this BE force is unknown, right? So we can find this BE force by solving this joint E or by solving this joint B. So let's solve this by this joint E, and let's assume that this BE force is acting in this direction. Let's say that BE force is acting in this direction. This is the assumption, right? So we do not know the correct direction of this BE force. So to find this BE force, first we have to find this angle. Let's say this angle is alpha. So now if I say that let's solve this joint E, right, and if I draw all these forces at this joint E, so right, so at this joint E, if this is the direction of this CE force, so at this joint E it will be acting in the opposite direction, remember, right? So this is that CE force. Now if I draw let's say this is that joint E, so then this will be DE force which is acting in the horizontal direction. This is DE, this one is EF, this one is 6 kilonewton, right, and this one is CE, and BE is acting at some angle, right? So let's say that this is that BE force, so this is that alpha angle, so we have to find this alpha angle. So now we have this triangle, so alpha will be equal to tan inverse this 4 divided by 6, right? So 4 divided by 6, and we solve this, so then alpha comes out to be 33.69 degrees. So now we know this alpha angle, right? Now if we apply the summation of forces along X, if we apply the summation of forces along X equal to 0, now as we can see that this DE is acting in the positive X direction, right? So I will write DE, and we know the magnitude of this DE. So what is the magnitude of this DE? So this is 4.13 kilonewton. We know the magnitude of EF as well, right? So what is the magnitude of EF? this 3.38 kilonewton, so I will write this as 3.38 kilonewton, and the CE magnitude is 5.50, right? So we will write this as 5.50 kilonewton. Now if I apply the summation of forces along x, so this is acting in the positive x direction, so I will write 4.13 plus, this is acting in the negative, so I will write minus 3.38. and if we resolve this BE force into its components, so it will have one component in the negative x direction, and that will be the cos component, right? So I will write minus BE cos of this angle, this is 33.69, right? So this is 33.69 degrees, and this will be equal to 0, right? So the only unknown is this BE. So this single equation will give us that BE member force. When we solve this equation, so we get BE equals to 0.901 kilonewton, and since it is acting away from this joint E, so this means that this is the tension force, right? So now we know the forces in all the member of this given truss. So this is the solution of this particular problem.